This lesson we will be looking at series circuits, and our question for this lesson is, how does current flow through a series circuit? Our keywords for this lesson are circuit, series, current, charge, amperes and ammeter. First of all, we have a knowledge check to complete, so make sure that you pause the video and answer all 8 questions before the answers appear. Here are the answers. So for the first question, the unit of charge is coulomb. The symbol that we use for that is a capital C. If current flows in a wire, electrons are what is moving, so it is the flow of electrons. The equation for work is work done equals force times distance. The equation for pressure is force divided by area. And the equation for weight is weight equals mass times gravitational field strength. Magnetic fields are vector quantities, and the unit used to measure heat is joules with a capital J. So make sure that you give yourself a mark out of 8. Make sure that you mark your work with a different coloured pen and do any corrections in that other coloured pen. So today we will be looking at circuits, and we have already had a quick look at a simple circuit. Today though we will be looking at circuit symbols. So figure A should be familiar to you already, but we can draw this circuit using circuit symbols, and figure B then shows what this simple circuit looks like using the symbols. We use symbols because it is easier to draw these than putting detail into what the components look like in reality. In science, we always try to make things easy for ourselves and make things simpler. And we must remember that connecting wires are always drawn as straight lines using a ruler. And as usual, drawing should be done in pencil. Below we have a table of the most commonly used circuit symbols. This table is in your booklets, but here we have it a bit bigger so that you can see, perhaps a little easier, the components and then the symbols that we use for each component. Now cell and batteries, they are very similar. They are both providing a power source for the circuit. So their symbol is a little bit different, but it is very similar. Lamps or bulbs, that name can be used interchangeably, so a lamp and a bulb, they are the same thing. And then ammeters and voltmeters we have briefly looked at already. So ammeters measure the current in amps or amperes, and voltmeters measure the voltage in volts. What I would like you to do then is take a couple of minutes to study the table of symbols. You then need to cover this up and try to redraw the table as best as you can from what you can remember in your booklet, or just on a separate sheet of paper if this is easier for you, but just try and redraw that table from memory. After that, you need to compare your new version to the original table, and in a different coloured pen you need to mark your table and make any corrections that are needed, and add anything that you are missing. Okay, so now we will talk about measuring electric current, and we have already spoken about these things, but it is mostly a refresher, but there is some extra information here. So as we know, The flow of electric charge is called electric current. So it's the flow of those electrons. That is what current is. The unit of current is amperes, shortened to amps. So I did mention before we were mainly using amps as the word for the unit, but the full word is ampere. Okay, and that is represented using the symbol capital A. Electric current can be measured using an ammeter. It's just an instrument that we can use to measure current. And then this bit is slightly new to you, so the symbol for ampere is a capital A, so that's the unit that current is measured in. But when we use current, for example, in symbol equations, we represent current with the capital letter I. So that is just something to be aware of, and if you are using current in symbol equations, then you need to represent it using the capital letter I. Now we will talk a bit about series circuits. So we know that the circuit below is one complete circuit. There is nothing missing. The circuit is complete. For these circuits, the electrons must go through the lamp. So there is no other optional path for the electrons to go. There is just one singular path for the electrons to go through. This is then what we call a series circuit. If two bulbs are in series, the current goes through one and then through the other. If in a series circuit one lamp is removed or broken, then the other lamp will not light. So by connecting an ammeter to the circuit, we can measure the current. So that is what ammeters for. They measure the current. Now an ammeter will work regardless of which way it's connected, but the best way to connect it into the circuit is for the red terminal of the ammeter to be connected to the positive side of the cell or battery. The reason for this is that current, because it's a flow of electrons, it flows from positive to negative. The long thin line on the cell symbol is the positive side of the cell. So that is the side that the red terminal of the ammeter should be connected to. If the ammeter is connected the wrong way round, then the number that it shows, the number for the current, will have a negative sign at the start. This sign then shows which way the current is flowing through the ammeter. And I've then circled on the circuit diagrams below. In these diagrams we've connected an ammeter into the circuit. So remember that the symbol for an ammeter is a circle with an A inside, and it's got to be a capital A. So what I need you to do is to watch the video. So there is the link underneath, or you can search the title, and it's the video by Peter Gravel in YouTube. And then, as an additional resource, use the simulator, the link is down below, to explore current in a series circuit. And what you can do in the simulator is you can pick the components that you use. So you can change your circuit and change the components to whatever you want to use. So you can have as many bulbs, as many batteries, the wires, the ammeters. It's got it all there for you to use. But the main thing that you need is you should be replicating the diagrams that you've got in your booklet. So they are at the bottom of the screen. These are the diagrams that you need to replicate in the simulator and fill in the table and answer the questions then in your booklet using what you see during this simulation. I will then go through the answers in terms of the numbers that I find in the simulation and then the general answers to the questions. Make sure you pause the video so that you have enough time to do all of these things before the video continues. So here are the circuits that I built using the simulator. So you can see that for the first one, the current is 0.5 amps in each place. Now it doesn't matter if you have different numbers in your ammeters, the main thing is that it should be the same number for both ammeters. For the second circuit then, with the two bulbs, I got 0.41 amps. It's okay if you have a different number, but of course the number should be the same at each 3 points. So make sure that the numbers that you have used in the table, they should be the same for each circuit. So, moving on to the questions then, the first question is compare the current in each position in the table. I have put that the current is the same at each point in the circuit. So the rule that I then came up with was that the current stays the same throughout the series circuit. So in a series circuit, at all points, the current will be the same. Make sure that you mark your answers and add any information that you need to add. The next question then asks, compare the brightness of the bulbs in circuit A and circuit B. So for this question you need to be paying attention to the lines coming out of the bulbs. I have then put circles around the bulbs to show clearer the difference between the brightness of the bulbs. So for circuit A you can see that the bulb is much brighter, the lines are much longer in circuit A than the bulbs in circuit B. Those lines are shorter, which means that the bulbs are dimmer. The next question then says to explain your answer to that question. Why are the brightness of the bulbs different in circuit A and circuit B? Now this is for two different reasons. So something that I talked through last lesson was about resistance. And the fact that if you add components, so for example an extra bulb, there is more resistance then with two bulbs than just one bulb. And this means then that the current is restricted. There's less current going through each bulb. The other reason is that the charge then is split between these two bulbs. Whereas for circuit A, the single bulb, all of the charge is going to that one bulb. Make sure that you mark your work. Make sure that in a different colour pen you make any corrections or add any extra information that you need. Talking about this idea of more bulbs in a series circuit being dimmer, if the bulbs are the same, then each charge will only give up half its energy if there are two bulbs. Because the charges are already spread out and they flow everywhere at the same time, they don't go from one bulb to another. The charges, the electrons, go through each at a particular time. So as the electrons are flowing around, they will go through one but then another, but all of the electrons are doing that and they're all spread around the circuit at different points. So the current is the same all the way around the series circuit. Now brightness depends on power, and power depends on the voltage and the current. So with two bulbs in series, you have half the voltage and roughly half the current. So the power in each bulb, and therefore the brightness, is a quarter, roughly, of what it would be if it was just a single bulb. Now we are going to look a little bit more about energy transfers, and this is something that we touched on last lesson, but it's something that I can now show a diagram of and hopefully help you understand a bit clearer about these energy transfers. So the battery in a circuit has a store of chemical energy. It is transferred then as electrical energy through an electrical pathway to the lamp. The lamp then converts this electrical energy into light and thermal energy, light and heat energy. It's this energy that then spreads to the surroundings through radiation and by heating. Now, make sure that you do your knowledge check to see how well you have understood the concepts of this lesson. Make sure that you answer all 10 questions and pause the video so that you have enough time to answer these questions before the answers appear. So here are the answers. The symbol for a connecting wire is just a straight line, but it should be drawn with a ruler and preferably in pencil. The circuit symbol for a bulb or a lamp is a circle with a cross in the middle. It is good practice to also show the lines on each side of the bulb for the wires. The long version, the full name of the unit for electric current, is amperes. This can then be shortened down to amps, and the symbol that we then use for amps or amperes is a capital A. The negative terminal of an ammeter is connected to the positive end of the battery. The rule for current in a series circuit is that it is the same throughout the entire circuit. So at any point in the circuit, the current is the same amount. Remember that current is the flow of electrons, the flow of charge. If more lamps or bulbs are added to a series circuit, then the brightness of the lamps decrease. This is not only due to the resistance, but also the charge. The energy is split between the two bulbs, so each of them get less. When we look at the change of energy in a series circuit with two bulbs, the battery has a chemical energy store. This is then converted into electrical energy, and it is transferred through the wires through an electrical pathway to the bulbs, the two bulbs. The bulbs then convert this energy into light and thermal heat energy. The energy is split between the two bulbs, so it would be less energy than if there was only one bulb. And it is an electrical pathway that the energy is transferred from the cell to the lamp or bulb. Make sure that you highlight your keywords. So a circuit is a path between two or more points along which an electrical current can be carried. So a circuit is essentially a loop that the electrons can flow around. So the current can flow around this loop. A series circuit is a circuit down which the current flows down just one path. So all the electrons go around the same path. The charge is the amount of electricity travelling through a circuit. The current is the flow of electrical charge, so it's the flow of electrons. Amps is the unit of electrical current, and an ammeter is a device for measuring current within a circuit. That is the end of the lesson. Thank you.